Hey everyone, welcome back to my channel. Just to reintroduce myself, my name is Sabrina Smai and I am a Microsoft student partner. And in today's video, I wanted to prove to you guys that you don't need to code in order for you to create a machine learning model, and you can train it all using Microsoft's Azure Studio. Let's get started. Now to get to the Machine Learning Studio, we type in this URL. So it's studio.azureml.net. All right, so it's going to take you to the home page, and it turns out that I'm already logged in. Let's go to my experiments. So this is the portal, essentially. These are my experiments that I already have running, but let's create a new one, a blank experiment. So the first thing we need to do is just look at some saved data sets and just take a look at the samples. But for this particular video, I was thinking of creating a model that is able to predict whether your next flight would be late or on time. So we can start off with flight on time performance. So we can go ahead and just drag that onto this blank slate here. We can start by visualizing this data to see what sorts of variables are on here, but you can see that there's year, quarter, month, day of month, day of week, the carrier, which is essentially the airline, the origin airport ID, so which airport it's at, and as well, this is the airport, this is the scheduled departure time, scheduled departure hour, the departure delay, so by how many minutes it was, the flight was delayed by, and then departure delay, and this is by 15 minutes, so whether the flight was delayed by over 15 minutes, yes or no. And then the scheduled arrival time, scheduled arrival hour, arrival delay by how many minutes. And then this is whether or not the arrival was delayed by over 15 minutes, yes or no. This is whether the flight was canceled or if it was diverted to another airport or another place. So that's essentially the data. Create a machine learning model that is going to predict this variable here, whether the arrival is delayed by over 15 minutes or not. Because if a flight is delayed by over 15 minutes, you start panicking because you're like, oh, I might miss my connection and whatnot. So that's what we need to do. So now that we have the data, we need to train the model and then analyze it. So we need to have some sort of algorithm to make the predictions. And of course you can use Python and write an algorithm, neural networks to analyze everything for you, but that's just way too complex. So let's use algorithms that were already created by researchers at Microsoft, and that's why we're using this Machine Learning Studio. So let's select columns. The first thing we're going to do is select columns, and we're just going to drag that over here, connect the two, click over here, and launch the column selector. So what we're essentially doing here is we're selecting columns from the data that make the most sense and the ones that are important and removing the ones that are not important. So what sorts of variables are going to affect the arrival time of a particular airplane? Potentially the month that you're traveling, the carrier, definitely, which airline makes a big difference. You guys have heard of many different airlines being known and reputable for being late and stuff like that, so that's a big factor. The origin of the airport ID is really important, as well as let's see. Also, the airport ID of the destination makes a big difference as well. The day of the month, yes, that makes a difference. Arrival delay, quarter. We're just playing around with the columns to see how our model will react. So the scheduled Departure time is also a factor that may affect. Did we miss anything? Day of the week, yeah, that makes a big difference. If you're traveling on a Friday or, you know, a Tuesday, that makes a huge difference. All right, let's just stick with that, okay? So we've selected a bunch of columns that we think are the most important that may affect our data. So now what we need to do is we have to take our data, split it into two, right? So when we split it into two, one part is going to be trained. So we're going to train that model. And then the other portion of the data is going to be, because we already know what the results are, we're going to compare the two to evaluate whether our machine learning model is accurate. So that's the way it's going to work. So there's a task called split. There's split data, so we're going to drag that over here. Okay. We'll attach it, and we're going to change the fraction of rows. So we're going to split it to 0.8. So 80% of the data will go through path 1, and then 20%, and path 1 is, we're going to train path 1, and path 2 is we're going to use that to compare whether the machine learning model is accurate or not. Okay, so now there's another task. The next thing we need to do is train our model, and there's a task called train model. So we'll drag that over here. Okay, so we'll attach that, and then we'll do launch column selector, and we're going to tell it that we want this to be the column that we're going to use. All right, so another task that we require is the two class neural network. If you guys don't know this, I have a blog post that I will post under the video that can help you learn about the different types. So we're selecting the two class neural network, and we're going to just attach it to the training model here. Now I need to look at the results, and that could be done by a task called score model. Okay, so we'll attach the training model here, and we're also going to take the data that we already know the results from to evaluate. So you take the trained data and the data that you already know the results for, and then you put it aside to see if the formula was actually right or not. That's essentially what the score model does. But the results that you get back are not going to make sense. So we're going to need to, we're going to have to add another model called the evaluate model. And this essentially just helps you digest the information better in such a way that makes sense. So we'll attach the score model here. Okay, so I think this is essentially it. So let's try running this, and this might take a while, but I just wanted to show you guys that there was absolutely no code involved in this. Okay, so we are running this. So as you can see, there's a queue and it's running, and it might take some time. So it's already been checked off, but the training the model is going to take the longest amount of time, and it takes a while because this model essentially gets sent to the cloud, and there's like a computer in the background that decides what sorts of mathematical calculations can be used to, you know, predict whether or not our next flight is going to be late. So this does take some time. I think it should take around 3 minutes, so I'll cut the video here. All right, so as you can see, it finished running. So what we're going to do now is that we're going to visualize the data. And as you can see, there's like this graph, and the closer, so this is your score, this blue line, and the closer it is to this diagonal line, it just means that your machine learning algorithm is straight out guessing. It is not accurate. So the more area there is under the curve, the higher the accuracy is. So as you can see that there is a pretty big curve and the area is not too bad. So let's check out what sort of score we got. So my accuracy is around 86%, which is actually not bad. But if you want to increase that number, you need to, there's so many different ways of doing that. You can change some parameters, you can change the class model, you can add more data, because I don't know if you realize that in the data set, it's only data for a single year. So if you add more data or add data about the weather and clean up some of the data, you can definitely increase this accuracy score by a lot. But this is still not too bad. This is still not bad at all. But yeah, so this is essentially how to create a machine learning model without a single line of code. Because Python is not my favorite language, and if there's a way to, write an algorithm without a single line of code, I'm all for it. I've used this a lot. It's a lot of fun to play around with, and yeah, use it. I'm excited to see what you guys do with it at hackathons, at work, different programs that you use this with. So I hope you guys enjoyed the video, and look out for more videos to come. All right, bye-bye.